Hi everyone. In this chapter, we're going to discuss unsaturated hydrocarbons, such as alkenes and aromatic compounds. Now, on this slide, you can see a few different pictures here. So unsaturated hydrocarbons are found in a lot of different items or even living organisms, like plants, medications, sunscreens, or aloe vera is shown over on the left there. Up above we have a cigarette here with some aromatic compounds coming off there. So we're going to talk about all of these different unsaturated hydrocarbons. Now, a couple of areas we're going to skip in this chapter are alkynes. Alkynes have two carbon atoms with a triple bond between them. This can also occur with nitrogen, but we're just going to skip that for now. Polymers. Polymers are basically long chains of repeating units. This is usually what makes up things like plastic, for instance, or nylon. But these aren't really used in allied health disciplines, so we're just going to skip it for now. Okay, so last time in chapter 11, we discussed saturated and unsaturated hydrocarbons. So remember that unsaturated hydrocarbons will contain a carbon-carbon multiple bond, like a double bond or a triple bond. So alkenes contain a double bond between two carbon atoms. Alkynes contain a triple bond between two carbon atoms. Aromatic compounds will contain alternating double bonds, and for our purposes, we'll just talk about benzene rings, shown here. So down below I have a couple of examples of alkenes and aromatic compounds. Remember, we're going to skip alkynes this chapter, but it's always good to know what an alkyne is. So down below I have the example of a molecule called ethylene, and this is a two-carbon molecule that has a double bond between its two carbons. Now, if we were to create a chain of ethylene compounds, we would create what's called a polymer, and ethylene is the building block for polymers that make up plastics, like those found in plastic bags. Again, we're not going to cover polymers in a lot of detail, but it's just good to know, in general what they are. And then off to the right, I have a molecule called vanillin. And we're actually going to see this molecule in our lab. But vanillin is what's found in vanilla beans. And if you have pure vanilla extract at home, the main compound in there is vanillin. And you'll notice that this has a ring structure with alternating double bonds. And this is called a benzene ring. Or you could also call it an aromatic compound. So we'll talk a little bit more about that later on. Now, the first thing we're actually going to do is cover how to name alkenes, because this will make the rest of the chapter much easier to digest and interpret. So naming alkenes is really similar to naming alkanes. The only difference is we do have a double bond present, so we have to indicate where that double bond is, and we want to make sure that it's in the longest carbon chain. So the first thing we're going to do is name the longest chain that contains the carbon-carbon double bond. So even if you have a group coming off of your molecule that's really long, you want to make sure that this carbon-carbon bond is in that chain. So sometimes you might find that your carbon-carbon double bond is maybe not part of the longest possible chain. So you just want to be careful with that. Now, remember when we were naming alkanes, we ended everything with ANE. So we had methane, ethane, propane, butane, etc. But for alkenes, we're going to use ENE as our ending. So that just comes from ENE alkenes. Then we're going to number the longest chain so that the CC double bond gets the lowest number possible. And we're also going to locate the CC bond with the lower numbered carbon. So for example, let's look down below. So in the first example, we have 4 carbons in a chain, and the double bond is between carbons 2 and carbon 3. So the way we're going to name this is if we have 4 carbons, we know that typically we would call that butane if we're treating it as an alkane. But we're just going to change that ending to ENE to indicate that we have a double bond. Then we want to indicate where the double bond is. So we have to choose between carbon 2 or carbon 3 to indicate where it starts. And we want to use the lower number. So we're going to say that the double bond starts at carbon 2. So that gives us 2-butene, which you already saw down below. Similarly, if we look at the example below that and count the total number of carbons in our chain, we have 1, 2, 3, 4, 5, 6. So if this were an alkane, we would call it hexane, right? But because there is a double bond in this chain, we're going to call it hexene. Now, we could have numbered this going from left to right, 1, 2, 3, 4, 5, 6. But that would tell us the double bond starts at carbon 4, if we're picking the lower number there, which we should. But if we number this from right to left, that tells us that the double bond starts at carbon 2. And we always want to pick the lowest number possible. So we're going to call this 2-hexene. Another thing to notice, if we look up at our 2-butene example, notice that the double bond isn't shown directly bonded to the carbons because there is a hydrogen here. That's okay. It's understood that the double bond is between the 2 carbons and that the hydrogen is actually bonded to the carbons separately. So just keep in mind this hydrogen isn't part of the double bond. All right, so now let's look at examples where we might have an extra group attached to our chain. If that is the case, so if you have a branched alkene, then we're going to locate and name any attached groups, and then we'll just combine all of the names into one name. So looking at our first example down below, we have 1, 2, 3, 4 carbons in a chain, and that chain includes our double bond. Then we have a branch coming off, so a group that's attached. And let's see, this would be called methyl. And we want to make sure to number everything so that the double bond has the lowest number possible, followed by any groups. Okay, so let's start from left to right because the double bond is on that first carbon on the left. So 1, 2, 3, 4. All right, so that means that our double bond starts at carbon 1 and the methyl group is on carbon 3. So putting this all together, we have 4 carbons. So we're going to use the prefix BUT There is a double bond, so we use the ending ene for butene. The double bond starts at carbon 1, and then the methyl group is on carbon 3. So we have 3-methyl-1-butene. And remember to put little dashes or hyphens between the numbers and letters. All right, let's look at a more complicated one down below. So we can already see that the longest carbon chain has 6 carbons. So that would normally be hexane, but there is a double bond. So this would be hexene. And we want to make sure that the double bond has the lowest number possible. So this would start at carbon 2. And then we have this branch or group coming off, and we can see that it's a methyl group, and it's on carbon 4. So that would be 4-methyl. And remember that the branches or groups that are attached to the main chain come before the main chain. All right, so now just some clarification here and a reminder. When we were discussing how to name alkanes, if we had multiple groups attached to the main chain, then we had to add a prefix such as di, tri, tetra. Sometimes we had to use t or sec, for instance. And remember that we also had to list our groups in alphabetical order. Now, when you're taking into account the alphabet or alphabetizing, you ignore the following prefixes except for iso. So iso does get counted in our alphabetical listings. So as an example, if we're looking at isopropyl and dimethyl as our groups, we are going to look at the I in iso, but looking at dimethyl, we're going to ignore the di prefix and just focus on methyl. So isopropyl would come before methyl. It might be tempting to say, oh, propyl, that's what we focus on, and that will come after methyl. But because we have iso in front of propyl, that does count. However, looking below, if we are comparing T-butyl and pentamethyl, we're going to ignore the T and the P. So we're just focused on B for butyl and M for methyl. So again, the only prefix that you have to even consider when you're alphabetizing is iso. Otherwise, just use the regular names like methyl, butyl, etc. Okay, so now let's look at how to name alkenes with multiple double bonds and multiple groups that are attached to the main chain. So in step 1, we're just going to follow the same naming instructions for alkenes with one double bond, except we are going to use those prefixes like di, tri, tetra to indicate how many double bonds we have total in the chain. So for example, if you have 2 double bonds in a chain, we would call that diene. If you have 3, that would be triene. If you have 4, it would be tetraene, etc. So you could keep going. Typically, we'll probably only see 2 or 3 in a chain if there are multiple double bonds. Now, we also want to indicate the location of all of our double bonds, and we want to make sure we're using the lower number. So down below, let's look at the first example on the left. And we're already shown that the main chain contains 4 carbons. So normally we would call that butane, right? But notice that we have 2 double bonds in the chain. So we're going to drop the ANE ending and write, well, we're going to keep the A actually. Otherwise it'd be butadiene, which I don't think we want to use that name. So we're going to put an A in there just to make it sound better. And we're going to call this butadiene. Okay, so now we numbered our carbons already, and we want to make sure that we're listing the lowest number possible for each double bond. So the first double bond is at position 1. The next one is at position 3. So that gives us the 1,3-butadiene. Then we also have 2 methyl groups coming off of the chain, and it looks like they're at positions 2 and 3. So we're going to be redundant and list 2,3-dimethyl in front of 1,3-butadiene. Let's look at a cyclic example, so a cycloalkene. And this one has 2 double bonds. So when you're numbering the double bonds, again, you want to make sure that you're giving each double bond the lowest numbers possible. So for example, here we already have them numbered, but you wouldn't want to start here, for instance, and go around the ring, because then the first double bond would be between carbons 1 and 2, but the second double bond would be between carbons 4 and 5. And as you can see, the way they're actually numbered, it gives the second double bond a lower number. So we just want to make sure we're giving those the lowest numbers possible. Now we also have a methyl group attached at carbon 2, so we'll want to take that into account. Now this ring structure has 5 carbons in it, so normally we would call that cyclopentane. But because we have 2 double bonds in the ring, we're going to replace the Ne with diene. So this becomes cyclopentadiene. And then we want to indicate where those 2 double bonds are. So the first one starts at carbon 1. The second one starts at carbon 3. And then the methyl group is at position 2. So we would add 2-methyl in front of 1,3-cyclopentadiene. So some of these names can be really long, but hopefully you're starting to see the pattern for how to name them. So let's do some practice problems. So I'm going to give you some compounds or alkenes, and I want you to try to name them on your own first. So once I'm done drawing them, you can pause the video and try it on your own, and then when you unpause, we'll go over it together. All right, so our first one looks like this. We'll start with kind of an easy one there, and then let's make it a little bit harder with the next one. And then we'll do a cyclic one. Oh, and let me just clean up my structure here. There we go. All right, so see if you can name these, and then when you're done, you can unpause and we'll go over them together. Okay, so let's start with the first one at the top. How many carbons do we have in that longest chain? 5. So normally, if this were an alkane, we would call that pentane. And remember, I do have flashcards from the last chapter with all of those prefixes. So if you're having trouble remembering the prefixes, just go through those flashcards. Make sure to practice. Okay, now There is a double bond in our structure, so we want to change our ending to ENE instead of ANE. But we also have to tell, whoever, maybe it's another scientist or a student, where that double bond exists in our chain of 5 carbons. So, do we want to number this from left to right or right to left? Left to right, because that will give us the smallest numbers possible. So 1, 2, 3, 4, 5. And the double bond, it looks like, is between carbons 2 and 3. So we're going to pick the lower number, carbon 2. It starts at carbon 2. Okay. Now, are there any groups attached that we need to account for? Nope. It's just a single chain, so we're good. It's 2-pentene. Now let's go to the second molecule. How many carbons are in the longest chain that includes the double bond? 5. And do we want to number that chain from left to right or right to left? Left to right. So 1, 2, 3, 4, 5. Okay, so the double bond starts at carbon 1. So that would be 1-pentene. But it looks like we do have a branch coming off of our main chain. And what would we call that group? So it has 2 carbons, so it would be ethyl. And we have to indicate where the ethyl group is. It's on carbon 3. So this would be 3-ethyl-1-pentene. And I'll just put a box around that there. So 3-ethyl-1-pentene. Now let's look at our last example. All right, so we've got 2 double bonds in a ring. And how many carbons are in the ring? 6. So normally we would call this cyclohexane, but we have 2 double bonds. So we're going to call this cyclohexadiene to indicate that we have 2 double bonds. Now we also have to tell people or, other students or other scientists where these double bonds are, or else they might end up getting the wrong molecule. So we want to number everything so that our double bonds start at the lowest numbers possible, but we also have a group attached. So we want to make sure that also has the lowest number possible. So for example, let's say we start at the bottom and just start numbering around the ring. Okay, so the double bonds would start at carbons 1 and 3, so those are low numbers for them. But the methyl group is at position 4. And we want to make sure it has the lowest number possible. So a better way to number this, see if I can number it without erasing everything. A better way would be to start at the methyl group up here. Oh, is my pen not working? There we go. 1, 2, 3, 4, 5, 6. So that way the methyl group and that first double bond are both at position 1, and the second double bond still has the lowest number possible at carbon 3. Okay, so let's just indicate where the double bonds are. So they're at carbons 1, 3, and then our methyl group is at carbon 1. Okay, so the full name is 1-methyl-1,3-cyclohexadiene. Okay, so I hope that helped a little bit with learning how to name alkenes. Um, and again, it's very similar to naming alkanes, but you just have to keep in mind that double bond and use a different ending there. All right, so I will see you in the next video.